Good morning. I'm Ankita Agrawal from IT Department, Acropolis Institute of Technology. I'm here with the topic linear regression in machine learning. Firstly, let us see what is linear regression in machine learning. So, linear regression is a simple and the easiest popular machine learning algorithm. It is a statistical method which is used for the predictive analysis. Now, in the prediction, we usually take the continuous or the real numeric data. Means the variables that we will be using that must have a continuous nature, like sales of any of the commodity or items, salary of a person, age of a person, product prices. These all come in under the category of continuous data, which means we have a numeric number. Another category is that we have for the data is categorical data, that is used basically for categorizing into certain number of categories. Just like example for that can be like that male and female, category of the male and female, category of few colors. So the outcomes for those things will be under the few categories only. In the linear regression, we will be show the linear relationship between a dependent variable and a it can be more than one independent variable. But whenever we use a single independent variable with a single dependent variable, it is called the linear regression. So, since linear regression shows a linear relationship, which means it finds how the value of the dependent variable is changing according to the value of independent variable. With the help of the graph, it is shown over here that the dependent variable is shown on the y-axis and independent variable is shown on the x-axis. Now the line of regression, the bold line indicated with the black color, shows how many data points are coming on that particular line. Means that it is showing the linear relationship between the two variables, that is dependent variable and the independent variable. Now, if we implement linear regression using Python, we have number of libraries that come into existence for its usage. Simple linear regression is a type of regression algorithm that models the relationship between the dependent and the independent variable. Now, the key point in the simple linear regression is that dependent variable must be continuous in nature, means it must have a numeric value. It can be an integer value or it can be a floating point value. It has two objectives: the model the relationship between the two variables. Like if we take an example between the income and the expenditure, or we take the another example, it can be taken as like experience and salary. How the salary of an individual vary with the help of the experience. Or else we go in new observations, like forecasting for the new observations. If we are going for the weather forecasting according to the temperature, or the revenue of the company according to the investments in a year. Linear regression can be better explained in the mathematical way with the help of the equation y is equal to mx plus c. It can also be explained with the above equation, like y is equal to a naught a1 plus a1x plus e. That means a naught is the intercept of the regression line, a1 is a slope of the regression line which tells whether the line is increasing or decreasing, and e is an error term. For a good model, best fit model, it will be negligible. Or it can be taken into different terms, so y is equal to mx plus c. Now, if you are going for the simple linear regression algorithm implementation with the help of Python, so what I have done is I have taken a data set, that is a CSV file, in which I am having two variables. The one is salary and the second is experience. So what I'm trying to do with this is I'm trying to draw an regression line between the salary and the experience, where the salary is a dependent variable and experience is an independent variable. Salary, how it is dependent variable? The first question that comes in our mind is how salary is dependent variable. So experience of a person or an individual will be fixed. that have a fixed nature, but salary will depend upon the experience of that particular individual. So for that, we are trying to build our model that with how much experience a person is liable to get a certain amount of salary. The goals of this problem is number one, that to find out if there is any correlation between the two variables, to find out the best fit line for the data set, and how the dependent variable is changing with the independent variable. So firstly, we do the data pre-processing. For the model implementation, the very first step is data pre-processing. Now what comes in the data pre-processing is that whatever data is available on any of the source, like from the internet or from wherever we are taking, that must be in a proper way that can be used further for the implementation of the model. So for that, in the data pre-processing, we do the cleaning of the data. For that, we have to import the file that we are using. Secondly, we have to look for the null values if there are any. Now, if there are any null values, and how we have to replace those values, either it can be replaced with the help of mean, median, or mode. Here the central tendencies come into the existence. So depending on our nature of the data, or on our problem statement, that what we are trying to interpret from that particular data, it depends. The null values must be sorted. Thirdly, we look for the outliers. If any of the outliers are there, what are the outliers? Firstly, the question comes is, what are the outliers? So outliers are the abnormal values that if they are evaluated in our data set, so they will change the nature of the central tendencies, means they will change the values of mean, median, and mode. But many of the times that are not acceptable, so we remove the outliers, and that can be done with the help of the box plots or the violin plot. Now firstly, we import the libraries. The first is import numpy as nm. Secondly, matplotlib.pyplot as mtp. Thirdly, pandas as pd. So within numpy, we will do the numerical calculations whatever are required for our data set. Secondly, matplotlib is basically used for the data visualization. So how we will visualize the line of regression and the y variable and the x variable, so that will be done with the help of matplotlib. Thirdly is pandas, which is basically used for loading the data set and reading that data set. Now I've taken the data underscore set as a variable in which I'm storing salary underscore data dot csv file. Now in this, firstly, by looking at the nature of this data set, that how the salary is dependent on the experience of an employee. So for that, I'm dividing into X and Y. Now how do we divide it into X and Y is we have the two columns like this. The years of experience is a first column and salary of the employee is a second column. Indexing is a 0th column. So in this, the dependent variable is years of experience and the independent variable is years of experience and dependent variable is salary. So in the variable X, I am taking the value of the independent variable, and in the value of Y, I am taking as a value of dependent variable, that is salary. This is how it looks like in the form of the data frame. Now total number of observations that I am having is 30. So what I am doing is taking 20 observations for the training set and 10 observations for the testing set. Now I split the data set so that we can train our model using the training data set and then test the model using the test data set. So splitting the data set into the training and test can be done from the sklearn library, that is scikit. From the for that, which module we will be taking into consideration is model underscore selection. So from sklearn dot model underscore selection, import train test split. From the train test split, we will divide the data into the training and the testing. So here I've taken as x underscore train, x underscore test, y underscore train, and y underscore test. From the from the model train test split. Now x and y are the variables that are independent and dependent. Test size is 1 by 3 that can be taken according to us, that how much data we want to put in the training set and how much data we want to put in the testing set. Random state is equal to 0. I've taken it as 0. It can be taken it as a different number also, that according to our requirement or the according to the requirement of our problem statement. Now fitting the simple linear regression to the training set. Import the linear regression class of linear model from the library scikit-learn. Now create an object of the class named as regressor, fitting the simple regression model to the training dataset. So from sklearn.linear model import linear regression. Here regressor is equal to linear regression, the class that we have taken into consideration. And now regressor.fit, in the fit model what we will be taking as x underscore train and y underscore train. The fit method is used to fit a simple linear regression object to the training set. In the fit function, we pass the parameters as xtrain and ytrain, because this is what we want to fit in our model, and depending on this, we will take the result of the testing model. So fit the regressor object to the training set so that the model can easily learn the correlations between the predictor and target variables. Now predicting the test set result. Again, coming to the x and y value, that is dependent is salary and independent is experience. Our model is ready to predict the output for the new observations. In this step, put the test data to the model to check whether it can predict the correct output or not. Firstly, create the vector y underscore predict and x underscore predict, which will contain the predictions of test data set and the prediction of training set respectively. Prediction of test and training set result y underscore predict is equal to regressor.predict, in which we will pass the parameter x underscore test, because on the testing data only we are trying to predict the value of y. That means with the test of x, that is the independent one, we are trying to predict the value of y. Again, the same thing goes in the vice versa. We predict the x value with the regressor.predict, in which we take the parameter x underscore train. Now what we are doing is visualizing the test training set results. Visualize the training set result. Use the scatter function of the pyplot library, which we have already imported in the pre-processing step. Now in the scatter function, we will create the scatter plot for the observations, where the x-axis plots the years of experience of the employees and y-axis plot the salary of the employees. In the function, we pass the real values of the training set, which means the year of experience x train and training set of the salaries y train, the color of the observations. Plot the regression line so for this use, we plot function is used from the pyplot library. mtp.scatter, in this we have taken x train and y train. Color is green, that means the green dots are represented with this. mtp.plot x train x predicted, color dot red. Title is that what we have given for the salary versus experience, the training data set, and x label stands for the title of the x axis, y label stands for the title of the y axis. mtp.show will show the output of the scatter plot.